We are discussing about horizontal translations. So first, let us try to understand the graph, the parent graphs or the base graph. So what is this kind of graph? There is a straight line here on the uh, say first quadrant and third quadrant. So this is a linear graph. That means it has a straight line. The function can be fx equal to x, that is y equal to x. So y and x are equal. Then this kind of a graph. So this shows that it's a quadratic graph. This is a linear, like linear means the power is 1 and here the power is 2. The maximum power is 2 and it has to be 2. So this is fx equal to x square. This is the graph. Then this is one of the graph which shows first and second quadrant a straight line. So can you say it as a linear? No, it's an absolute value graph. That is x with the modulus. So positive means this just has gone up because of the modulus sign. So negative value will not come, it will always be positive. For all x there will be a positive y value. Then this kind of a graph, what kind of graph this is? This is a square root graph. That means fx equal to root x. This is a square root graph. This is how it is shown. Then this kind of graph. This graph is a cubic graph. It was x square. Now we have a x cube here. Fx equal to x cube. Which kind of graph is this now? This kind of graph is exponential. Exponential means some number, say a to the power x. Now this x is the variable. This is a constant. So we have to identify the function equation that is different from the rest. Which of this function equation is different from the rest? Y equal to x plus 3. So we have y equal to x square, x whatever it is, but there is a constant being added. If I would have added say plus 4, then this is somewhat different from others, but here the 3 is added to the function. That means it has some kind of difference from the other. That is, we are not at the origin. First of all, when we are talking about this, all the graphs you have seen like this or this, every graph was from the origin or to the origin. But in this case, in mathematics, the transformations, this is a kind of transformation. This refers to the manipulation of the graph of a function or a relation like the translation or a reflection or a stretch. Now the result of the transformation can be called the image graph or an image function. See, if you have a balloon, now you just press it, it will change its shape. If you elongate it, it will change its shape. Now that change shape will be called as the image graph or the image function. So a transformation is indicated in a function equation by including a parameter in the parent function. Okay, this transformation is indicated in a function or in a function equation by including a parameter in the parent function. So y will be equal to a f b x minus h plus k, or in some books it is k here, b here, or c like this. Okay. So what are the families of function? Let us start with y equal to f, that is x minus h. See, y equal to fx was our function. Now we have x minus h. This has been added. So this represents a horizontal translation. There was x and h was subtracted. So h greater than 0, that is the translation is to the right if h is greater than 0. That means if you put h equal to 3, then you need to shift 3 units to the right because it's a translation to the right. So you have to shift it to the right 3 units. Right? You have xy. Now if you have added x plus 3, that is you are trying to find out y equal to f x minus 3. Just notice this replacement because this is 3. We just place because this represents a horizontal translation. That is why we put a 3. So what has happened? This was y equal to fx, our function. But now y is not equal to fx. Y is indeed or actually x minus h. So what you have done? This is the x minus h. So this h or this 3 from this point to this point, this 3 unit, from here this point to this point 3 unit. So we have shifted it. Now if h is less than 0, then what? Similar thing, but on the left side, this side. So the translation will be to the left. If h equal to minus 2, it shifts 2 unit left. So if we have x, y, and this is x minus 2y, what we are going to do here is, see, this is minus 2, you can say, but in the function we say x minus of minus 2, x minus of minus 2, right? Just understand this, you can say replacement. This is very important. This is showing that when we have, see, x plus 3, y equal to x plus 3, or y equal to f x minus 3, here we have x minus 2, so we have just replaced it as minus 2, just in order to show that the translation is to the left. So now this function is nothing but y equal to f x plus 3, x plus 2, sorry, right? This is just x plus 2. So x minus of minus 2 is x plus 2. So now 2 units to the left. This was original function, now this is f x plus h function. So with the horizontal translation, the domain may be affected, but the range will always stay the same. Let us consider one graph y equal to fx. This is y equal to fx, this is our graph. Now can this function fx be written as an equation? Piecewise function. This is one piece, a, b, then b, c, then c, d. Graph y equal to fx plus 1. That is horizontal shift 1 unit left. I hope you know by now that is shifting 1 unit left. So key points mapping we can do. Let us see. This xy, this is x minus 1y. Then minus 2, 0, this minus 2 and 0, this point. You can subtract this minus 2 with this minus 2 is there. So we say minus 2 minus 1 and y, that is 0. So minus 2 minus 1 is 3, minus 3. Then minus 1, 3, how this will be shifted, right? This will be shifted to minus 1 of minus 1 and 3. So minus 1 becomes 2, 2, 3. Minus 2, comma 3. So this becomes minus 2, comma 3. What are we doing? We are just subtracting 1 because it is x minus 1 now. We are subtracting 1 from here. This will be minus 2, 3. Okay. Minus 1, 3 has become minus 2, 3. How about this 2, 3? This is 2 and this is 3. This point we are talking about. And this point was minus 1, 3. This was minus 1, this was minus 1, 3. So we have shifted it, right? So this is now 2, 3. So 2, 3, just subtract 1 from here. So you get 1, 3. And this point is x is 5, y is 1. This is 5, 1. So you subtract 1 from 5, you get 4, 1. So this is the key point mapping of function fx plus 1. It was initially fx. Now we want to shift it, or you can say horizontal shifting to 1 unit left. That is why we added 1 to this. And of course, we are just, when we are adding in the function as 1, we are subtracting here. So now the function is exactly like this, but shifted 1 unit to the left. So domain of image in interval notation is minus 3 and 4. See, it starts from minus 3 and it goes up to 4. Range of image in set builder form will be this y. See, this from this point to this point, y is there, and it is varying from 0 to 3. So y is such that y is in between 0 and 3. 0 and 3 are inclusive. So notation assumes real number. So we have to write the equation of a function after a horizontal translation of 3 units to the left. So we know how to do this now. Y equal to fx plus 3. This what we write, and x is replaced because y equal to fx, if it was our function, then in order to translate it 3 unit left, we have to add a 3. Y equal to x square, it will become x plus 3 whole square. how will be the coordinate in mapping notation? X, y will be, see, this was x plus 3, and we know that when it is 3, we have to subtract 3 from here, x minus 3y. So x is replaced by x minus 3 in this ordered pair, xy becomes x minus 3y. So 3, 9 will become what? We have to subtract 3 from here. So this will be 0, 9. 3 minus 3 is 0, 0, 9. Now we have y equal to x square plus 2x plus 1. What do we do with this? We have to replace x with x plus 3. So put x as x plus 3, x as x plus 3. And just reformulate it. It will be, rearrange it. It will be y equal to x square plus 8x plus 16. And what are the coordinates in mapping notation? If we have x, y, what we have done? We have just put x equal to x minus 3, because same here. So this 316 in this case will be what? You have to subtract 3 only. 3 minus 3 is 0 and it will be 16. We have another function which is fx equal to 2 under root x plus 3. So we have to write the equation of the function after a horizontal translation of 4 units to the right. Now it is right. So we replace x by x minus 4 in the function equation. So y will be, if it was fx, it will be fx minus 4. Please understand, it will be x minus 4, but we are going to add to the later section. So x minus 4, so just put x as x minus 4 here, 2 under root x minus 4, y equal to 2 under root x minus 4 plus 3. Write the equation, transform form now gx. Let us take one more equation. This is what? Y equal to fx. Now just see one equation, and we just translated it to this, say, right shift 2 units. So horizontal shift is 2 units, right? This is 2 units. So what we have done is we replaced x with x minus 2. So y equal to fx, so we replace y equal to fx minus 2. And what will be the mapping notation? Xy will be equal to, now we have to add x. See, if it is x minus 2, we have to add 2. This is the replacement. So domain in the interval notation, the original was minus 2 to 2, right? From this point to this point, x. And what will be the image? It is now from 0 to 4. See, this is 4 if you say this is 4. Now this we have shifted it already. So it starts from 0 and goes up to 4. This is the image. So this is a bit idea about the horizontal translation. Thank you so much. Take care of yourself.